Welcome back. This is the second segment of section 7.2. Likely we can, the previous one was a little bit shorter. This one might be a little bit longer, but it's a good way to break this up. And I recall we were talking about situations where you have two sides of a triangle and a non-included angle, which is your side-side angle congruence, which is not congruent, by the way. That results in a couple different options depending on the value of the angle that you have. If it's acute, you have one sort of path to decide how to approach the problem, and if it's obtuse, there's another. And obtuse is really the simplest one, so I'm going to start with that and kind of show you a way that it breaks down, and then modify it a little bit so that it works. So let me move over here and get to work on drawing an appropriate looking triangle, and I want to kind of show you what the errors look like when we get to the point where it doesn't work. So this is section 7.2, page number 2. So let's start with the obtuse case, or maybe they call it a situation for side angle. And I'm going to go ahead and draw an obtuse triangle so that I can kind of get the setup correct. Call this angle A, and so maybe we call this side B. This will be side C. So this, whatever this angle is, will be C, and then we have opposite side A. So I'm gonna identify A as being a known angle, B being a known distance, and A being a known distance. So let's first construct the situation where it doesn't work, right? So let's say that angle A is an obtuse angle. Let's make it, I don't know, let's say 105 degrees. And let's make B equal to, I don't know, let's say 25 feet. Now remember, the criterion to make this not work is that A would have to be smaller than B. So let's just make A a little bit smaller than B and call it 21 feet. So if this was the setup and you didn't realize that this is an impossible triangle, what would be the first step? Well, you have an angle. If you're going to use the law of sines, you have an angle and its opposite side, right? So that's got to be the basis of how you find the other stuff. We don't have a method to directly calculate distance C, but we do have a method to find angle B. And once we have angle B, then presumably we could find angle C. Sorry, this is angle B down here. We could find angle C, and then we could do the same thing again with the opposite pair. So how would we do that? Well, the first thing we'd say is, okay, well, let's start with the parent equation, which is that sine of A over A, this is the known stuff, right, is equal to sine of B over B. Okay? Known, known, known. This is what we're after. So if I rearrange this equation, I'm going to get sine of B equal to B over A times sine of A. Okay, so it's possible that I might get a solution out of this, but let's just see what the right hand side is equal to, because remember, the next step you'd think would be to take the inverse sine, but you got to verify that this is actually in the range, right? That this is a reasonable number. So let's see what we get. If we take B, which is 25 over 21 times the sine of 105 degrees, this equals 5 divided by 21 times 105 sine. And notice we get a number that's larger than 1. So we've got that this is equal to 1.14991, etc. Why is that a problem? Well, because the range on sine is -1 to 1. This will we simply cannot get an answer out of this. If you try to take the inverse sine, you're going to get something that's an error. So we get error. It is possible, and maybe it's because the numbers I picked, it is possible to actually get something that that maybe would make sense, but I'm maybe not. I think this is usually the situation you're going to end up with, is that you end up with this ratio that's larger than the product of these two is larger than 1, and you end up with something that's an error, and that should be your clue. No such triangle. And again, this is the situation where A is smaller than B. It just simply cannot reach on this side. Now, it's possible if you pick the right number that maybe you'd end up with something that could reach on the opposite side. And I guess depending on how you calculate it, you might end up with an angle that actually comes out as it wouldn't come out as a negative number, but you know, you might see another solution that possibly works for whatever reason. Anyways, okay, so this is the situation where you have an obtuse, but the side angle doesn't give you any result at all. Now, how can we fix that? We could fix it by just maybe changing the value of A or B so that the criterion is satisfied. So let's do that real quickly. Same sort of setup. I won't redraw it, but I'll take most of the things and say, it's just a repeat. So section 7.2, page 3. So similar setup. A is equal to 105 degrees. B is equal to 25 feet. And now the only thing I need to do is have A be larger than 25 feet. So what should it be? Let's say like 32 feet. That ought to work. Okay. So back to the original sort of plan, I'm going to try to find angle B out of this. So I would solve that equation again. So I've got sine of B equal to B over A times sine of A. And now here's the thing. This will actually come out to a number less than 1. It'll be positive, but it'll be a number less than 1. And I can say that with confidence because sine in quadrant 2 is positive, B is positive, A is positive. You have 3 positive things basically multiplied together, so the number will be positive. And as long as it's less than 1, which is this is the criteria for that, A has to be larger than B in order for that to be less than 1, we will be able to take the inverse sine. So B, in this particular case, becomes the inverse sine of this B over A sine of A. Okay, now why we talked about this in the last couple sections in 2.4. When we're taking an inverse trig function, we want to be super careful, right? Because it doesn't necessarily have the only solution. Now in this case it's okay because this is going to be a positive number less than 1, which will give us an angle that comes out of this that's acute. And that is exactly what we expect to come out of this problem, because if you look at the diagram, this will make B an acute angle. You can't have an obtuse angle and another right or obtuse angle in a triangle. It just doesn't make any sense. So this will produce a viable solution. And as we calculate it here, I've got the inverse sine of, let's see, B over A, so 25 feet over 32 feet, times the sine of 105 degrees. Okay, and so B will come out as 25 divided by 32 equals times the sine of 105 equals. Notice it's a number that's less than 1, but positive. And so when I take the inverse sine, I'm going to get an angle of, look at that, it's pretty close to 49 degrees. But remember, I am going to have to use all of that because the next step is to calculate the next angle. So I have 48.993 301,135 degrees. And I'm just going to hold this number for a second. This calculator can store up to 3 numbers, so I'm just going to go ahead and store that because I'll probably use it in the future. I have this M1 up here that says that memory is used, so it's stored in space number 1. Now, what about C? The next step would be I don't have the third angle, so I can't get the third side. So I need to find the third angle first. So find C. C is going to be equal to 180 minus A minus B, which in this case is 180 degrees minus 105 minus this awful thing, right? Don't use 49, use this awful thing, which is 48.99301,135, and that's why I stored it in the calculator, so it's easier to make that subtraction. So this comes out as 180 minus 105 minus, repeat that number, equals. So this becomes 26.00698865 degrees. And again, I'm going to store this as well because I'm going to use it in the next calculation. So store 2. Now see, I have a memory 2 there. So memory 1, and it's kind of a little hard to, it's a little out of focus in small numbers, but memory 1 is angle B and memory 2 is angle C. So when I use it, I'll just recall it. So now I have angle A, B, and C. I have side A and B. I need side C to complete the calculation. So C is equal to, well, if I can, I want to use angle A instead of something else, because that was the one that I was given first, and it's probably the easiest to use. So therefore I need the side pair A. So A times sine of C over sine of A. And this is going to be equal to, well, A is 32 feet. Sine of C is this crazy thing up here. So I'm going to kind of write it in there, but I'm going to use my memory recall function to actually punch it in. And then over sine of A, which was 105 degrees. And this is why I did that storage, because it's a pain to have to reproduce that number. And if you, granted, this one's really, really close to 26, but if it was something kind of in the middle, it can cause a rounding error. This one probably won't, because it's basically 26 to 4 significant digits. But anyways, so be it. So when I go to calculate this, I've got 32 times recall 2, the sine of 26.006, then divided by the sine of 105, and there's my solution. I've got 14.5263. And remember, this is in feet. So notice I did not make any approximations. I have not applied anything involving significant digits or anything else, because again, the rule is you only apply those at the end, and only one time. So you're not using a rounded number to then calculate another number that will be rounded in the future. Okay, so let's look at, let's sort of summarize the solution here. We've got A was given as 105 degrees. B was calculated. Now, how many significant digits should I use? This is a kind of a, an interesting question. It probably shouldn't be any more accurate than A. And if we had maybe used different feet measurements, maybe it would be, but it is 2 significant digits, 2 significant digits, something with 3 significant digits. The product is 3 significant digits. An inverse sine, much like trig functions, the rule is to just keep the same number of significant digits, which is not how it really works, but is the way that the book advocates it. So this answer would be 49 degrees. C, similar argument. When you add all this business up, you've got a subtraction of something with the position of significance. The least position of significance is actually in the degree, whole degree. So C must be equal to 26 degrees. It's just totally random that I got something that was so close to a degree measurement. Little a was given in the problem as 32 feet. Little b was given in the problem as 25 feet. And then finally we have C. It's derived from computations involving something with 2 significant digits, 3 significant digits, and this weird computed number, which ultimately only has 2 significant digits, because it's a calculation that involves things that, you know, has a position of significance. So it's 2 is the minimum. And so we need to round this number. And again, this is one of these numbers that people have a real hard time rounding because of the 5. But it only has 2 digits of significance, so you need to round it up. And that's 15 feet. So there's our solution to a slight modification. We have two situations with side-side angle. So now the question is, let's just kind of let that sit for a minute. And I'm going to probably, I mean, because these do, like I said, these do take a long time. So I'm going to come back to another situation where we have the acute situation with A in the third, probably the final video for this, the final segment for this section. But rather than trying to make this one really long, I'll just leave it at this. Here's the obtuse case. We'll come back to the acute case in the next video. I will see you very, very soon.